Hi, I wanted to record a quick video to highlight some learnings I've had with the integration of machine intelligence into knowledge work. I've worked in the field for 40 years and seen great evolution in both knowledge work as well as machine intelligence, of course, and thought I would try to share some observations that might be useful to people newer in the field. Um, let's talk about the application I'm going to use as an example. I know that using coding examples alienates many people, but it's a very useful use case. Software engineering is because it's a very rich knowledge worker activity. And it's not only something that we're all familiar with in the computer science realm, but it is absolutely something that is intuitive and easy to understand, never more so than it is right now with the ability to do vibe coding and the like. So, about several years ago, I wanted to create a pipeline that could use different diffusion models um, to generate images from either text or a reference image and text. And I identified over time, a set of 13 configurations that I like to kind of explore and play with. Some of those are Flux 1, some are Flux 2, some are stable diffusion models. It's a great use case because even though at a high level the pipelines are the same, there's like a pre-production phase, a production phase, and a post-production phase. You could think of it at that level of abstraction. It's accurate. There's incredible variation as you get down to increasing levels of detail, and that makes it a very ripe problem for machine intelligence to be integrated into the software development workflow. The model configurations themselves are one thing. They're dependent on different pieces of software to run them. So there's several hundred modules that are used in this pipeline, and some of those modules are used in the majority of them, but some are used only in a subset of the 13 models. And so even in some of the models, there's different versions. So you might have version 13 that's needed for model 8, but for model 2, you need, version 15 of the software. And so you can imagine that at that level of detail, it's mind-numbing and not something I'm particularly good at or enjoy. So I thought it'd be good to show you a little bit up front what the pipeline looks like here on the right-hand side. It is, a very simple web interface. It's got a lot of functionality, but I'm going to start off and use the 13 model 13, which is STXL, which is a fast model. It'll be good for this example, but you can see there's 13 different configurations in there. My sort of hello world example with image generation is a frog on a log in a bog, which I almost always use as my initial. And I'm not going to change any of the parameters here, but I'm just going to generate the image. You will see it start up, and you'll see it generate and show us previews along the way. And this program is actually a client piece and a server piece. This is the client piece, of course, that you're seeing now. And the server piece sits on the back end and employs the different pipelines. The software engineering tool I used for building this, the harness, if you will, was Claude Code. I sometimes jump over to Codex just to explore it and to see if it can understand the code that Claude Code is generating, but Codex and Claude Code are both excellent tools now. And so they're the harness, and then I use different versions of the model or different models within Claude Code to experiment and try to understand what's possible. So the latest version of ChatGPT or the GPT models is 5.6 Soul, I believe. And you can change the thinking mode, and then for Anthropic, I use both Fable and 4.8, Opus 4.8, but 5.0 just came out. I don't have access to it yet, but you can see that this did a pretty nice job. But you can imagine the variability, right, of what can happen here, because there's dozens, if not hundreds, of software modules. There's 13 different model configurations, and there's a lot of parameters to play with. And so, this is a modestly complex application, but one which I've used over the last couple of years to help me kind of learn the art of the possible. So when I learned about software development, I learned the waterfall approach. It's still a very useful point of departure for people. But we started off with requirements, kind of what do we want the software to do, a design, which is how it's going to work, but also continues to specify requirements in the design. For example, how the user interface is going to look, detailed design, going down to code and unit testing. Unit testing is just very local testing of the modules that you're working on. And then integration and system testing comes next. That's when you're testing the whole pipeline. And then, of course, you use the software and you learn about it, and that makes you want to make revisions to it kind of ultimately as well. Now, I developed the requirements for this app that you see over here iteratively, right? So I didn't have a perfect set of requirements, but let's assume for a second that I did. If I dropped in just this set of requirements and the model had perfect knowledge of all the diffusion models that it's going to use, all 13 of them, if it had perfect knowledge of my environment, if it had perfect knowledge of me to understand how I might want to utilize an interface, a user interface, that type of thing, it could just go ahead and run, and one perfect pass, the ideal perfect pass, it would generate software that would meet my needs. Now, of course, we live in an imperfect world, and for example, these software modules that are changing constantly. Yesterday there was a change to a module that created a problem for me, so I had to work with AI to fix it. So there's a continuously changing ecosystem here. But also my preferences change, right? I might like a different type of interface. I'm trying to condense as much here on one page as possible because I now know where everything is, but initially this was a much more entry-level interface with more basic stuff. So the world is constantly changing, and there's a tremendous amount of detail to know. You can imagine that if there's a new API for a module of software that came out yesterday, that the AI that wasn't trained on it. So it has to know that it has to use a tool, it has to go out and search, and Claude Code does all this. It'll go out and get the code, but it often discovers that it needs to do that after it tries to do something and it fails. And therein is the other end of the spectrum, which is trial and error, which is the way most of us ultimately learned. So a couple of years ago, when I started building out this pipeline, which has been a couple of year project that I continually update and change and modify and try to performance tune and all these other things, it was a lot more trial and error. The system, Claude Code, had to try a lot of stuff. It failed a lot. And then based on its failures, it went back and kind of fixed things. And so it had less knowledge. And knowledge is both information as well as reasoning capabilities, right? It's not just the flat knowledge, it's what you do with the knowledge. And so these models have gotten smarter. The harness has gotten more effective, the Claude Code harness, and therefore the knowledge has kind of gotten better. It's never going to be perfect. So the amount of trial and error has been kind of greatly reduced. And I think this is really important to understand when you're automating knowledge work. It's that, okay, this is a complicated activity. Almost any creator or maker function is going to, kind of fit roughly into this particular pattern. You might be making a banking product or an insurance product or a consumer good product or whatever, but you're going to fall into some sort of process like this. And just an excellent frame of reference for knowledge work. And I'm not particularly worried about being replaced here because as it's running, it has to ask me questions about my preferences, what I wanted to try. For example, this morning it ran out of memory on a model that's been working fine, and we had to decide how we were going to handle it, whether we were going to just cut the headroom or if we were going to try to find a different version of one of the modules that could maybe run that model more efficiently or effectively. And my environment might change, so that's happened a couple times where I've changed the versions of Ubuntu Unix running on my server, and that can create all sorts of issues that it needs to know about as well. So you can imagine I'm continually adding models here. So model 14 is something that I'm considering right now, and that'll create a new requirement or set of requirements or modify the existing requirements more accurately that the system will need to be able to handle. So where are we? I have a coworker, right? Pair programming is one of the things it's called in computer science, but I have a great one. I can expect that it's going to continually get smarter, but it's still going to rely on a lot of trial and error. And as I go through repeated evolutions of the software development process, of course we don't do waterfall anymore, but we still go through a process. As I go through it, this gap here is going to require me to intervene, and therefore I need to know what the model is doing, right? It can ask me a lot of questions, and I could be a return monkey and just keep hitting the return key, but I need to probably be more informed than that. That's actually bit me a couple times, so I make sure that I pay attention or I engage it. And the explanations, by the way, in Claude Code and Codex are getting even better. So they're starting to really engage me more effectively in the process. And so as we're automating knowledge work, especially more complex activities, where the criteria is that there's a tremendous amount of variation, we're going to continue to have involvement, but the process is going to change, and it's going to be a moving target. It'll always involve some trial and error. It'll always involve lots of judgment, but of course the friction will reduce over time. And in something like this application over here, you could see that I added functions where if I go into some of the models that are have additional capabilities, I want the code to know about those additional capabilities and be able to take advantage of them. Now, it could store that all in flat code. That's a pretty weak way to do it, but it could also build a repository and have a repository of models. That's a suggestion that the software Claude Code made to me to create a repository of models and then draw the information about those models from a repository. That's a pretty significant refactoring, which will make this a more durable and resilient system. And it was suggested by and will ultimately be implemented with Claude Code. But it's not going to be able to do it completely without me. Because there's lots of decisions to be made, but it'll focus my attention on those decisions. It does give good recommendations, but oftentimes its preferred recommended path is not the one I choose. So, sometimes that's for learning purposes, but most of the time it's for just differences of preferences and values. And so, as you're using machine intelligence in knowledge worker activity, it's important that you kind of rethink old ways of doing things and reimagine the process. But it's also important that you find ways to live in this middle area, the middle of the Oreo here, where the AI has pretty good knowledge, but it has gaps and makes errors, and therefore you have a level of engagement that's less than perfect knowledge, but isn't pure trial and error. And this is where we as users will collaborate with our machine intelligences.